Hello and welcome to Vodcast 15.5. In this Vodcast, I will overview Earth's moon. Before we venture out and start touring the solar system, it'd be nice to stay in our own backyard and talk about Luna, which is the name for our moon. For about as long as mankind's been looking up at the sky, this has been the marquee feature. Some general characteristics for the moon include a diameter that's 1/4 of Earth's diameter. Our moon is unusually large compared to its parent planet. Another characteristic that's very important that gives us clues to the moon's formation is its density. With a density of 3.3 times that of water, the moon's quite a bit less dense than Earth. However, the moon's density is very comparable to Earth's crustal rocks, which are the rocks you find close to Earth's surface. The moon probably has a small iron core, but it is very small compared to the overall size of the moon. Another characteristic of our moon is that the gravitational attraction is 1/6 that of Earth's gravity. So for me, weighing about 280 pounds here on planet Earth, I'd only weigh about 47 pounds on the moon. Our moon also has no atmosphere and it has no water, so erosion as we know it here on Earth is non-existent on the moon. The moon is also geologically dead, meaning that plate tectonics are no longer active. Now, water erosion and wind erosion are non-existent on the moon, but the moon's surface is reshaped by the bombardment of micrometeorites. Here on Earth, with a thick atmosphere, most meteorites won't make it to Earth's surface. But the moon doesn't have that protective atmospheric layer, so essentially any micrometeorites or space debris will make it to the surface. One thing I really like to do is debunk misconceptions. And one misconception I often hear is that the moon doesn't rotate. This might make sense because we always see the same side of the moon, but the truth is the moon does rotate. At this point, I'm going to show you a brief 1-minute video from NASA that explains the moon's rotation.
This one's for all you romantics out there. When you stare up at the moon, do you ever notice you always see the same side of the moon facing the Earth? A lot of people think it's because the moon does not rotate. Surprise, the moon does rotate. So how can we always see the same side? First, let's start the moon rotating on its axis. You would think we would see all the sides. But now, let's put the moon in orbit around the Earth. The time in which the moon rotates once is the same amount of time it takes to orbit around the Earth once. The moon's rotation and revolution speeds are synchronized, so the moon is in a type of synchronous orbit. The result? From Earth's point of view, we always see the same side of our rotating moon. By the way, if you were on the near side of the moon, you would see our rotating Earth fixed in the same spot in the sky all the time. Think about it. Learn more about our moon at nasa.gov.
You can say what you want about the music I put in my videos, but I'm pretty sure we all can agree that the music I choose is better than the music NASA chooses for its videos. In all seriousness though, that was a very good video that demonstrated a very important concept regarding the moon's rotation and revolution about Earth. Now I'd like to present to you the scientific consensus on how the moon formed. Earth's moon is far too big to have been gravitationally captured by our planet. And as I explained in the Nebular Theory video, early in the formation of our solar system, there were a lot of collisions occurring between very large rocky bodies. The scientific consensus is that the moon formed as a result of a collision between two of those large bodies. In fact, one of the bodies was Mars-sized, and the other body was our semi-molten Earth. This collision occurred approximately 4.5 billion years ago, right after our planet had formed. The collision didn't occur head-on. It was a glancing collision, almost like two billiards balls hitting each other at an angle. And when that collision happened, a huge amount of material from Earth's mantle was ejected and thrown into orbit around our planet. Over time, that material coalesced to form the moon. Now, this hypothesis is consistent with the number of facts we know about our moon. That ejected mantle material would be very iron poor. And because of the fact that the moon does not have a very big iron core, it makes sense that the material that it formed from didn't have a lot of iron in it. Another key fact is that the density of the moon is almost identical to the material found in Earth's mantle. Earth's average density is higher than the moon's, but that's because we have a very dense core. The moon's density is comparatively lower because it doesn't have the large dense core that Earth has. And then one final consideration that's kind of interesting is that every year the moon moves slightly further away from us. Long ago in Earth's past, the moon would have looked a lot bigger in the night sky, but every year the moon's moving a very, very small distance further away from our planet. The final consideration in this vodcast is the lunar surface. There are two types of terrain on the moon. There's Maria, which is Latin for sea, and there are the lunar highlands. I'd like to start by overviewing Maria. The Maria are the dark regions of the moon's surface. These tend to be fairly smooth lowlands, and they originated from asteroid impacts and lava flooding long ago. Keep in mind that because the moon's composition is nearly identical to Earth's mantle composition, we see many of the same rocks on the moon's surface. So we shouldn't be surprised to see evidence of basaltic lava flows and igneous rocks on the moon's surface. The second type of terrain on the lunar surface is the highlands. The highlands are the lighter colored, densely cratered regions of the moon. And in the image shown on the screen, you can clearly see those cratered regions in the bright spots. Those craters were produced by impacts with meteoroids. And because the moon doesn't have an atmosphere to burn up meteoroids to any extent whatsoever, those meteoroids are capable of making some pretty significant pockmarks in the moon's surface. The highlands make up most of the moon. And when it comes to the backside of the moon, or to drop a Pink Floyd reference, the dark side of the moon, the highlands make up that entire side. And lastly, in terms of age, the highlands will be older than Maria. Okay, that concludes this video podcast. In our next Vodcast, we will look at the terrestrial planets, and in the Vodcast that follows, we will consider the Jovian planets.